How do you think the vaccine has impacted our response to malaria since we started talking about malaria vaccines?
Okay. Well, we've been talking about malaria vaccines, I think, for as long as vaccines have been around, right? And in one way, that question is hard to answer because we don't have a lot of data yet. So the rollout, we have two malaria vaccines, and they're very similar, and they both target the stage of the parasite that's transmitted by mosquitoes. So they prevent infection when they're effective, and we've only, I mean, these vaccines were approved. So the first vaccine was approved in 2021 by WHO and the second in 2023. And so we really have not, so countries started implementing and using these vaccines in 2024. So it's only been 2 years, but and a few things, I mean, I guess two important things are clear. One is we knew from the beginning, from the clinical trials with these vaccines, they are not the measles vaccine. They are not a magic bullet that's going to protect you for life. The malaria parasite is much more complicated than the measles virus, and so it's much harder to make that kind of vaccine. And so interventions like bed nets and seasonal chemoprophylaxis and an insecticide spraying are still absolutely necessary. And the worry was, of course, that the vaccine would cause countries to stop spending on these interventions, and that has not happened. But together with these interventions, the vaccine can be very effective. So I think on its own, in a child in a malaria endemic area, it's about 45% effective for a year. But when you employ these other interventions, and it's been tested, particularly with seasonal chemoprophylaxis, which is where we give drugs, let's say, to prevent malaria 3 times during the rainy season, the efficacy can be up to 80 and 90%. So the thinking is that this vaccine will significantly add to our, the things we have to combat malaria, and will definitely make a difference. And I think that that's probably true. In fact, the WHO was worried about approving the vaccine after the very first phase 3 clinical trial, and did what they would call a phase 4 trial or a pilot study with over 800,000 kids in 3 African countries. And that was from 2019 to 2023. And so we have that data, and it already shows about a 13% reduction in childhood mortality when you add the vaccine compared to places where they didn't have it. And now I think it very well could end up being higher in other countries.
It was right from the outset of the vaccine that we knew it would not be the magic bullet that magically ends malaria in its entirety. There are different phases in the malaria parasite infection, and I know your research laboratory focuses on the infective phase. So regarding this landscape, what progress have we had so far in our quest for the magic bullet? Have we given up totally on magic bullet mentality as far as malaria response is concerned?
I don't think we've completely given it up. I think we could do better than I don't know if we'll ever have a magic bullet vaccine, but I do think that we can do better than what we have, and that there are ongoing efforts to do that. And so people are looking for, and I think that the way forward that most people in the field agree on is to target multiple stages. So you alluded, I study the stage that's transmitted by mosquitoes, but ultimately you have a blood stage infection. This stage that I study that is transmitted is you don't even know you were infected. And then about 10 days or 2 weeks later, after the mosquito bite, your red blood cells are infected and you have a blood stage infection and you're sick. This is what's responsible for all symptoms of the disease. There has been a lot of progress actually on targeting the blood stages as well. And so I think, and there are promising vaccine candidates. Simon Draper at Oxford is working on this, and he's identified a protein complex that's necessary for the parasite to enter red cells. And he has tested his vaccine in phase 1 trials, and it's safe, and it's being tested in other clinical trials now. But something like that, combining this vaccine with a vaccine that targets another stage, so having a multi-stage vaccine, I think would definitely enhance the efficacy of a malaria vaccine.
Yes, in designing these multi-stage vaccines, at what point do you think we should be talking about seeing them integrated into each other? Is it at the clinical or design stage, or when they've individually reached advanced phases in their clinical trials?
Well, the blood stage vaccine, which is targeting the protein Rh5, that I think within the next few years will be in a phase 3 clinical trial. And once you have positive results from that, it's then you can sort of talk about combining it. And would
Yeah.
they be given just simultaneously in the same syringe or separate? That is all details that will be worked out once you know what you're dealing.
What does the funding for malaria vaccine research currently look like? If you can give me a rough idea of what the landscape looks like.
I think it looks different in different countries. And initial basic science research, which is where it all starts, is funded by countries. It depends on the robustness of their research landscape. And that's where everything starts. So RTSS, which is based on the circumsporozoite protein of the malaria parasite, which is one of the current vaccines, that all started with research at NYU by the Nussensweigs. And that was funded by the National Institutes of Health and funded by USAID. USAID, I mean, it doesn't exist anymore, but before the Trump administration eliminated it, it didn't really fund basic research anymore. So, in Germany, there are a lot of malaria researchers, in the UK, and this is all sort of government funding, the Wellcome Trust, right? The Medical Research Council in the UK. So it varies. I've been in this field now for 25 years. And what I've seen is that infrastructure for this kind of research has really increased dramatically in malaria affected countries. Uganda has exceptional research facilities. Malawi has some, Mali, many countries. So I think, what's happening, which is great, right, is African countries are also sort of performing some of the research now and the work.
From a researcher perspective, what knowledge gaps do you think we still have regarding malaria that could make a lot of difference in how we respond to it?
I think there's so much we don't know. It would take me hours to tell you. What we know is the tip of the iceberg. I can, so yeah, the more we find out, the better, right? And this parasite is a very complicated organism. It has outsmarted our immune system. It has figured out how to manipulate mosquitoes. And so there's just so much we don't know. But areas that are being pursued now, like describing sort of novel ways in which the parasite feeds itself when it's in the red cell, that could lead to new drugs, right? The circumsporozoite protein, which is the basis of the 2 malaria vaccines, that's one protein. And sporozoites have many other proteins that we know very little about. So research into those. And the Rh5 candidate vaccine, right, that was found through basic science research, looking into how does the parasite enter the red cell. And then on the mosquito end, right, what happens in the mosquito? Can we prevent infection in the mosquito? We don't know a lot about, like, how the interaction between the mosquito and the parasite and what the parasite needs from the mosquito in order to maybe interfere with that.
Do you think all of these answers are needed to end malaria as a leading cause of death?
No, I think it's very helpful, right? Basic research gave us the 2 malaria vaccines we have now, but you can also take an empirical approach and just test a million things, right? So there's different ways to get to that endpoint, but I'm a scientist, so I like the science.
How do you think malaria research has evolved over the years since the time you started and now? I know we seem to be so much obsessed with genomics, extensive genetics right now. But when you started out, what was it like? And what do you think the current trend suggests about the future of malaria research?
Well, I think research has always been driven by discoveries in technology, right, or by new technologies. And even 35 years ago, when this protein was discovered by my mentor, and I was not even in his lab yet. I was too young to be in his lab at that point, but he was using the then novel hybridoma monoclonal antibody technology, and that's how he found it. And so these technologies help, and I can tell you, like, a lot of the genomics technologies and omics technologies we have are making it, we can, when the malaria parasite fights back, which it does constantly, and becomes resistant, let's say, to our drugs, which it does all the time, we can figure out how it did that much more quickly than we used to be able to because of the omics technologies, right? So they're helpful. They're yeah. And as we discover new technologies, we'll find out, we'll use them to discover more of the parasite's secrets, because there are many of those secrets.
You've highlighted how many secrets the parasite is carrying that we are still yet to discover. Does that bother you that we've been dealing with this disease for ages, and yet we still have so much unknown about this particular disease? Does it bother you, or is it something that is common to other diseases too?
I think it's common to other diseases. I think it's common to everything. There's so many things we can learn and that we don't understand. So it doesn't bother me. I have been doing this for a long time, and I can say that in my 25-year career, it's only been in the last 5 years that I go to meetings and people are optimistic. And that's fantastic, right? There has been a change now. Like, when I was a postdoc or a young assistant professor, like, a lot of non-governmental organizations and even the NIH sort of, we're not going to fund malaria research because you guys are never going to make a vaccine. And so the tide has changed, right? And I think that it's great.
Is it the malaria vaccines that are responsible for the optimism, or what is driving this
Well, I
optimism?
think the malaria vaccines are huge. That was a huge milestone. Even though they're not magic bullets, they are an important tool now. So that's definitely part of it. I think also some of the discoveries of, how does the parasite get into the red cell? We always knew some things about how it gets into the red cell, but the parasite is capable of changing how it gets into the red cell. So everything we found, and then we would try to attack, the parasite would just change and escape anything that we did. And then the finding of RH5, which all parasites always have to use. So now this is a site of vulnerability, right? This is an Achilles heel. Like that's exciting, right? So I think the area, the sort of downside is we're seeing in Southeast Asia, we're seeing decreased sensitivity of the parasite to artemisinins, which are a major, major pillar of anti-malarial treatments in endemic areas. And although the resistance isn't exactly the same, we're beginning to see decreased sensitivity to artemisinins in sub-Saharan Africa. And, there are new drugs in the pipeline, but only in the pipeline. And so that's an area that we still really need to bring forward.
There were a lot of hopes and a lot of expectations around other interventions like monoclonal antibodies and, like you also said, new drug classes. I was thinking the pace, the rapid nature of how we did things during COVID, since we have a lot of attention now coming into malaria vaccine, for innovations in this space to also attract almost similar level of attention and prioritization in accelerating them to clinical trial stages. So what are your thoughts on those other innovations in the pipeline and the pace at which they are going in relation to their disruptive potentials?
Well, I think that the pace at which the pipeline proceeds depends not on the destructive potential of a particular infection, but on who's getting that infection. So the reason the COVID vaccine proceeded, the time frame for the malaria vaccine, the COVID vaccine, the clinical trials and its approval were done in a year.
Yeah.
And that time period was 15 years for the malaria vaccine. So I think, there's a huge bias here, right? And I'm not sure that that's going to change. The problem in the United States now is that vaccines are not being funded, and vaccine work is being defunded, right? So hopefully that will change, but I don't think there's any urgency there on the part of the fund, the government funding.
What do you think will define the future of malaria?
Well, I think there'll be two things. One, I think that in these heavily endemic areas where children are dying, I think we're going to be controlling it much better. And I think fewer children will die. I also think with climate change, that areas where malaria is transmitted may broaden, and that we may be seeing more malaria in places that had previously eliminated it. I don't think we're going to eradicate this parasite. But we have to learn to live with it and have it not kill us. We have to come to a détente with the parasite.
So, what about your research team? What are you and your team members optimistic about in your line of research?
Well, this protein that is the basis of the current malaria vaccines, we still don't really understand how it works. And we don't know very much about how its structure, like what it looks like. And we're working on that. And it's been interesting and fun. And maybe we will, see things and find things that will aid the vaccine effort. That is our hope. Why isn't your country doing more? Like these other African countries are really putting a lot of resources into infectious disease research and just don't. Am I just not aware of what's going on in Nigeria, or does it not happen?
We have a lot of epidemiological ongoing, and I think Nigeria is heavily contributing to the body of knowledge on the public health response. And of course, the large population also provides a much bigger picture into these malaria outlooks. And I think from my experience to visiting some of the countries that have these clinical trials, size really, really matters. Burundi is a really, really small country, which means if you're trying to do some research that could have very massive impact on large populations, you may just want to start at very, very controlled and small populations. And I think that is probably the reasons why a lot of these international organizations supported researches are located outside Nigeria. We have these collaborations that are probably intentionally chosen because of the size of this country to provide a really, really good overview. You can easily see and track what is going on compared to a country of 200 million. And mosquitoes fly everywhere, so you can't really, really distinguish it
Okay,
when you
that
have
makes
that
sense.
size. Yeah. Yeah, it's a good question. Thank you very
Yeah,
much.
very nice meeting you.
Nice meeting you too. Take care.